All right, we are jumping into 9.2. We've already talked about some different transformations. The one we're going to talk about today is called a reflection. Okay, the start thinking part says, what's the difference between a translation and a transformation? Can anybody tell me the difference between a translation and transformation? Yeah.
Like a transformation that changes size or something like that, or maybe shape.
Okay, so this is a change of size or shape. Something else though. Which one is the more broad? Yeah, exactly. So a translation is a type of transformation. So if we were doing like a Venn diagram, we would have transformation, and inside one of them would be a translation. Does anybody have any questions on that? What does an isometry mean? Like, what does that mean if something is an isometry? Someone else? What does it mean about the preimage and the image? They must be congruent, is correct. So whenever you have the preimage and the image and they're both congruent, then it's called an isometry or a rigid motion. So what we're going to do right now is I'm going to bring up some different reflections, and you guys are going to look at it and come up with the definition for it. If you are at home, you can pause the video and take a look. Here is an example of a bunch of reflections. People at home, you can go over and pause, come up with the definition. People in class, I'm going to go over and put you in groups, and I want you to come up with the definition of what a reflection is. All right, who has a definition? Yes.
So, like, it's like a flipped triangle, like the shape is flipped.
Flipped over a what?
Or like a line, like a.
Fantastic. Okay, so we're going to put that down in just a second. If you have this, then you can see the figure is going to be flipped over the line. What do you notice about A versus A prime and B versus B prime and C versus C prime? They're equidistant from the line of reflection. Fantastic. Let's go ahead and put that into our definition. So a reflection is going to be a flip over a line of reflection such that A and A prime, or any point in its prime, are equidistant from the line of reflection. And you can see some examples here of reflections. So we got to fill out the properties of reflections. The point on the preimage and the corresponding point on the image are, we already just talked about that, equidistant from the line of reflection. Now, what do we notice about the orientation? Like if you look in a mirror, that's going to give you a reflection as well. What do you notice if you have the word Nike on your shirt and you look in the mirror? It is flipped. Fantastic. So the orientation of a figure is flipped. Here is an example of that. If you look and you go clockwise and it goes B, U, then G. So B, U, G, bug. And then you start after the transformation has happened, and you go clockwise and start from B and it goes B, G, U, and you're going in the same direction. That means the orientation has switched. Any questions on that? Okay, a reflection is a blank, meaning that the preimage and image are congruent. It's hard for me because I can't really call on people because we're recording it. I don't want to have your name in the video. Anybody? What is it called where the preimage and image are congruent? There's two different names. Which one of them? Isometry. Fantastic. Isometry or a rigid motion. They mean the same thing. Now, when we look at A to A prime, B to B prime, and C to C prime, it looks like A to A prime, B to B prime. If you look at all those segments, what is true about all of them? They are all parallel, and they are also perpendicularly bisected by the line of reflection. So that is how I'm going to be able to set up my application problems. Parallel, you know, same slope, You can write equations of lines. Darn, if we have parallel lines, I could go over and throw in some alternate interior angles. I can do a lot of stuff with parallel lines. And then perpendicular, you know that the slopes are going to be opposite reciprocals. A slope of AB becomes negative B over A. Does anybody have any questions about any of these properties of reflections? The process itself is insanely easy. So what you have to do, here's the notation. Instead of putting a T, big T for translation, they put a big R for reflection. This is where they tell you the line that you're going to reflect over, and this tells you what you're going to be reflecting. So this says that we are going to reflect over the X or the Y axis. You guys should know that the Y axis is this vertical line right here. Okay, if this is 1 to the left, where is our point going to be if we do a reflection? 1 to the right, and that's where C prime is. If this is 2 to the left, where's it going to be? 2 to the right, call it A prime. And this is 1, 2, 3 to the left, we are going to go 1, 2, 3 to the right. Call it B prime. Something feels funny here. Or is that fine? Did I? 1, 2, 3, 1, 2. Yeah, I did. It's going to be right here. Okay, cool. Now, how did I know that it was not right? Well, I know that it's supposed to be an isometry, and where I had my point, I knew that things weren't going to be congruent. That just didn't make any sense.
Wait, so where does B go?
B goes, so this B is 1, 2, 3 to the left. I accidentally went 4 to the right. I was supposed to go 3 to the right. Anybody have any questions? Let's go ahead and do some others. Occasionally, they're going to give you something like y equals 3. And you need to know if that's horizontal or vertical. Initials BM. Is that a horizontal or a vertical line if it says y equals? No, it's vertical. Well, it goes through the y-axis. So what is the only way you can go through? You mean horizontal, your original answer. Correct. Okay, so y equals 3 is going to be a horizontal line going through the y-axis of 3. 1, 2, 3.
Isn't that 4?
I don't think so. 1, 2, 3. That's 3. Okay, now our issue here is that some are below and some are above. I don't know how to do that. Well, think about, bring yourself to like first grade where they go over and folded a paper and you put some ink over here and then you folded it and it made the mirror image over here. And you're like, oh, that's cool. Let's do it again. And then you accidentally the second time put some ink that goes on the left, but then you get a little bit that goes on the right as well. So what happens to all the stuff that's on the left? It goes to the, when you fold this, it goes to the right. What about the ink that is on the right? Where does it go? Left. That's fine. So any point that's above will go below. Any point that's below goes above. So this point that is 1 above is going to go 1 below, B prime. 1 below goes 1 above, A prime. 2 below goes 2 above, C prime. And just make sure that it looks right-ish. Yeah, that's good enough. Anybody have any questions on that? This next one says x equals 2, initials, CT. CT, is that going to be vertical or is that going to be horizontal? Well, it goes through the x-axis. What is the only way you can go through the x-axis? Is that vertical or horizontal? That's the x-axis. Can I go through the this and be horizontal? No, it's going to be vertical. So this means it's got to reflect over that line. And we have the same deal here. We've got points that are on the left and some points that are on the right. So since this is left 1 unit, I need to go right 1 unit and put C prime. This is right 1, 2, 3, 4. I'm going to go left 1, 2, 3, 4. I'm going to put B prime. This is 1, 2, 3 to the left, go 1, 2, 3 to the right. Call it A prime. Does anybody have any questions on that? All right, what I want you guys to do is go ahead, people at home, go ahead and pause the video and try these two problems. People in class, go ahead and do these. Draw your line of reflection and do your reflection. Okay, first step is finding out where your line is. This is y equals 2. That's that horizontal line. This point is 2 above. We're going to go 2 below and put a point. This point is 2 above, so we're going to go 2 below and put a point. This point is on the line, so we connect them, and that's what it looks like. Anybody have any questions? Next one is x equals 1. That's our line right there. If this is 1, 2, 3 to the right, we're going to go 1, 2, 3 to the left, call that b prime. If this is 1, 2, 3 to the left, go 1, 2, 3 to the right and call it a prime. And that's 1 to the left, go 1 to the right and call that c prime. And when you connect them, that's what it looks like. Does anybody have any questions? Now, we have been focusing on reflecting over vertical lines or reflecting over horizontal lines. Now, this changes things up a little bit. If you have y equals a number that is horizontal, if you have x equals a number that is vertical, does anybody know what y equals x looks like? Diagonal, because technically that just means y equals 1x plus 0. So that would be a diagonal line that looks like this. What about y equals negative x? What's that going to look like? Yep.
That's going to go from the other side.
Yeah, it's diagonal going the other direction. Obviously, that's a crappy line. It's supposed to go through 0. Okay, there are actually rules like, oh, AB, if it reflects over the x-axis, is going to be negative AB. But that's just super confusing. I highly doubt you guys are going to memorize that. After we do it the other way, I'll show you the rules when it comes to y equals x and y equals negative x, but it's easier just to do it on paper. So on here, this says we are going to reflect negative 2, 2. Make sure you guys know how to plot points. It's going to be funny if you get to like the Aspire test and you're like, wait a second, is that the x or is that the y? So here is going to be what we are going to reflect, CD. And we are going to reflect over this line right here. So you're going to do the same exact thing, except for instead of counting full line segments, you're going to count diagonals. This point D, how many diagonals is it from the line of reflection?
1.
Not even.
Oh.
1/2. So how far do we have to go in the other direction? 1/2. So you're counting diagonals. Do you see how that is 1/2 of a diagonal and this is 1/2 of a diagonal?
Oh, yeah.
Okay, how many diagonals is C from if you take diagonals to get there?
2.
1, 2. So how many do we go? 1, 2. And that's where C prime is. C was located at negative 2, 2, and C prime is 2, negative 2. D is going to be located at 1, 2, and D prime is at 2, 1. What does it look like the rule is when you're flipping over y equals x? The rule would be, what do you do to your point? Just switch it. All it is x, y becomes y, x. So if you want to memorize that rule, good for you. If you just want to count diagonals, that works as well. The only time you wouldn't want to count diagonals is if it was like the point 132, 57 reflected over y equals x. That's a lot of diagonals to go over. It'd be much easier just to go, oh, just switch it, 132. Does anybody have any questions on that? Go ahead and plot these 2 points. People at home, go ahead and pause the video. We have the point negative 1, negative 2. Negative 1, negative 2 is here. 1, negative 2 is here. You're going to reflect that one, and then you're going to reflect it also over y equals negative x. So reflect that. People at home, as I said, pause the video, give this a shot. So on this first one, we already know the rule for that. You can just switch your points. So it would be -2, -1, and -2, +1. You can do that for this, or you can have the diagonals. It is half diagonal, go another half diagonal, 1.5, go 1.5, and that's where the location is. On this one, 1/2, 1/2, 1.5, 1.5, and there you go. This would be the location, let's see, -1, -2, and this location is 2, 1. And this one is, what was that? 1, -2, and that becomes 2, -1. Okay, so this is the deal. If you have x, y, if you want to memorize this, then you would switch it so it's y negative x. I would not memorize that. Isn't that the rule? Is that what happens? Or is it negative y negative x? It's negative y negative x. Okay, so if you want to do that, fine. I would probably not memorize that. If you want to memorize this one, the xy becomes yx. That's easy to memorize. The other one, you're probably going to mess up. Okay, anybody have any questions on that? The last thing we have to get to is we have to do some applications. I want to get some algebra in here. Remind you guys how to write the equational lines and stuff. So here it says, here is the point of A, here's the point of A prime. What's the equation of the line of reflection? What do you think is a good first step?
Plot the points.
I'd plot the points, and I'm not even going to be neat about it. I'm just going to like general location. 2, 4 is like here. A is at 2, 4. A prime is at 4, 10, right about here. A prime. 4, 10. There's A prime, and here is our line of reflection that we want. I'm going to call it line 1. Now, what are the two things you need to write the equation of a line? Because they want the equation of the line. You need the slope and a what? Y-intercept, kind of. You need something that'll get you your y-intercept. You need a point. So we have to figure out, using the information we have, we need a point that is on line 1, and we also need a slope of line 1. Does anybody have any ideas about how we can get either one of those things?
What's like the midpoint thing of the 2 points?
Great. The midpoint, we know that these points are equidistant from the line of reflection, so our point will be gathered by the midpoint. Let's go ahead and do that, I guess, real quick. 2, 4, and 4, 10. When we find the midpoint, it's 2 plus 4 divided by 2, 4 plus 10 divided by 2, 6 divided by 2 is 3, 14 divided by 2 is 7. So we now know a point that is on our line. We now need to know the slope of our line. Yep. Great. We can find the slope of AA prime and do the opposite reciprocal. So let's figure out what the slope of AA prime is. Well, it is y2 minus y1 all over x2 minus x1. 6 over 2, 3 over 1. So if that's the slope of AA prime, what is ER, Beck? What would be the slope of our line? Remember, they're perpendicular, so it's opposite reciprocal. What's the opposite reciprocal of 3 over 1? Okay. And now we just have to write the equation line. Y equals negative 1/3 x plus b. Sub in your point. 7 equals negative 1/3 times 3 over 1, because I'm just taking my x and my y from that point that we know that's on there. 7 equals negative 1 plus b, and b equals 8. And now we have our equation. Y equals negative 1/3 x plus 8. The negative 1/3 is from the opposite reciprocal. It is perpendicular. We got the 8 by knowing the midpoint is on the line, and we were able to substitute it in. Does anybody have any questions on that? All right, one last problem. A reflection, after a reflection, AA prime intersects the line of reflection at M. A is at 2, 4, A prime is at 8, 12. What is the length of AM? Good first step would be, let's plot the points. Here's A, 2, 4. Here's A prime, 8, 12. There's AA prime. They tell me that the line of reflection intersects AA prime at M. And they want to know, what is that? Any ideas on how we could find that? Someone other than the two people who have answered every question so far? There we go. What do we do? Distance formula for what? From where to where?
From the 2 points from 8 to 12.
A to A prime. So from 2, 4 to 8, 12. Let's find out what that is. X2 minus X1. Oops. 1 squared plus Y2 minus Y1 squared. 6 squared plus 8 squared. 36 plus 64. Square root of 100. Okay, so A to A prime is 10, but that's not what they asked for. They wanted A to M. What's A to M going to be? Half of it. Why? Because this is a perpendicular bisector. Does anybody have any questions on that? Okay, I'm going to give you the rest of the time. If you are actually working, you're going to get the homework done or almost done. The only small change you have to make, which I didn't pick up on, a different kid did, I said MNB has a reflection. Then the points I called them on your paper, MBN, it's supposed to be M prime, B prime, N prime, because after something happened, you should have primes. So just make sure you change that on your paper. All right, giddy up. You guys have the rest of the time. Honestly, you should be able to get this done in 12 minutes. People at home, thanks for watching.